So, welcome everybody. Can you hear me?
Yes.
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 Yeah.
Okay. So, well, this is the first lecture, and so probably there will be some, logistic problem as always. But anyway, so the first thing that I want to say is that this lecture is uh, here on Microsoft Teams and on YouTube. On YouTube, maybe the quality of the video is better, and so when I uh, show when I show you some code, probably the YouTube quality is well, more appropriate. But anyway, especially if you have a poor bandwidth. So, but if you want to interact, as I hope you want, you can just use Microsoft Teams and just it's not please do not use the chat or something else, but just raise your hands if you want, or just speak up, and I will answer your questions or whatever. Okay, so that's the idea. Of course, it's nice to me if I can see your faces, at least when you speak. It's not a problem to keep the camera off when I'm talking. Okay, that's the stuff related to the distance learning to which we are forced in this period. I really don't like to teach in this remote setup, but that's the well, the days in which we live. Okay, so let's start with some, organizational details. This is a course on programming in Python, and all the stuff, videos, or sort of the recordings of the lectures, and everything will come up on the course website. So please bookmark it and visit frequently, and so. That's the address that you can find in the slide. There is also this well, shortcut to remember the link. So my name is Mattia Monga, and so you can just use that name, mattiamon.ga/pyqb, Python for quantitative biologists. That's the idea. And please also fill in the survey that you find there, linked there, and subscribe to Zulip. It's just a forum. I prefer to use Zulip than just the email or something else, or the forum in Arial, because it's easier to keep organized the discussion. And please ask your questions there, or everything, because well, it's a forum, so I try to answer to everything, to all the questions. Even I know that you use Python in other courses, so maybe you could also have some question related to other stuff. And if I'm able to answer, I will happy to do that. But also, it's a forum. So the idea is that the answer is public, so it can help everyone. And also, you can answer to a problem that one of your colleagues has. So I think that using the forum is really important and useful. So please subscribe to that. Just to subscribe, there is a link, and you have to use your Unimi uh, email address as the login. And after that, you have to choose a password and so. There is also a survey. I saw that 4 people already answered to the survey, and I hope that you all answer to it. It's completely anonymous, and but for me it's important. It's my it's the first time that I teach this course, and actually it's your no, master's program is new. So that's the idea is to try to understand better which is the population of the course. So please answer to it and as soon as possible. So today probably or something like that. Okay. That's the logistic stuff, and there is also something to say about the course schedule. That's Mondays and Fridays at this time at 9:30 to or 2 academic hours. And we will have 40 hours of lecture, so in which I'm supposed to you know, give you lectures about Python and stuff, and 16 hours of labs. And those 16 hours are planned as face-to-face currently. They are planned face-to-face. I don't know if we will actually able to do them face-to-face, but the plan is that currently. And the first one will be on the 12th of March. And on the website, you can find all the schedule in, well, maybe in a way that it's more readable than the one that you can find in this slide. We actually we will use 3 different setups during the course. So we will start with a very easy one that doesn't need anything from your side, just a browser, and the first steps will on that platform. I will show you already today that. And after that, we will instead use a plain Python interpreter, and that's why it's very important that the first lab on the 12th of March we will try to connect or came in the lab because I'm going to help you in doing the right setup and using that. So that's the idea. And finally, in the last part of the course, we will use another different setup, but it's the Jupyter notebooks stuff, notebook setup that it's very popular in scientific practice, and I believe that you already met that in another course. So probably, but I think it's important to not just jump on that, but try to understand what happens. We have a tutor. I saw him connected, I think, so you can already tap him.
Yeah, I'm here.
Okay, and he is Davide Paulillo. He is a computer science master student, and well, he is intended to be a support on the course and the stuff, especially the practical stuff. So please make use of him. Okay. On the website, you can find a book also for it's not special actually. Every book on Python 3, every reference tutorial is okay. We will not do special or strange things. So every book is okay. The one that is linked on the website is freely available to Unimi students. You have to connect with your Unimi credentials and you can download it legally and freely. And also the printed version is quite cheap, so not free but cheap. And the outcome of the course, of course, it's a final test exam in which you will be requested to write small Python programs without help. So you should be able to write them by yourself. That's the idea. That's the learning outcome of this course. That's the and on that we will you will be evaluated. That's the idea. So, are there any questions on this stuff?
Yes, Professor, please.
Yeah.
I just want to ask about the final test. Is it in the form of a project? Because I come from MBB Masters, Molecular Biotechnology and Bioinformatics Master, and like we had one course which is Methods in Bioinformatics. It was like R programming, and the test was a project. At the end, we present our project, and the professors ask us questions. I just want to know exactly the form of the final test in Python.
Okay. No, it won't be a project. It will be something that you have to write at the moment. So you have to write a small Python program with my specification. So according to my specification. That's the idea. That's
Okay, Professor. Thank you.
okay. So any other question?
I'm Prof. I may introduce myself a little bit after I need to go.
Sure.
Just to say to you guys.
Sorry, I just want to say one thing that I forgot about. We are here on Teams and on YouTube, but actually on YouTube there is just my voice and just my video. So your well, personal data and your personal things are not on the internet at large, but this means that I probably repeat your questions when just to get the people on YouTube to understand what we are talking about. So, Davide, please.
Yeah, okay. So guys, I will not be present at every lessons, in particular on Monday. But you can reach me with Telegram, Zulip, whatever you want. It's more likely that you wanna type your questions onto Zulip so everyone can see it and can answer it. But if you wanna ask me something or do some exercises with me, just reach me, and I'll answer. I'll be really really happy to help you guys, or just maybe, I don't know, do some exercises, something in Python. I do really like programming in Python. I do use it for competitive programming. I don't know if you do know what it is, but yeah. So just reach me and talk to me. I'll be really glad to speak with you about the course, and I mean, whatever you want to talk. If it's about informatics, it's fine to me.
Okay, so thank you, Davide. And so Davide said that he's not going to attend all the lectures, but he is always available. I would add that the preferred way to communicate with us, David and me and everyone, is by Zulip. So that's the preferred way. It's actually very easy, and everything keeps organized and well searchable. So that's the preferred way. If you have some private stuff, so well, please use the email and or something else. But the preferred way is it's okay. So let's start. The Okay, so well, let's start saying some words about why Python. Actually, this was a precise requirement of the teaching committee. So it's something that was, well, normally it's actually quite, you know, strange for at least in the computer science, clubs, to have a course with the name of the programming language in the title of the course. We normally teach programming courses, not Python, programming in Python. That's why, because programming is actually a skill that you should learn independently from the language, even if actually you cannot learn to program without referring to a specific language. So that's the idea. It's Python. It's a good choice for your professional objectives, I think, because it's very popular in the scientific landscape. There are, you know, tons of scientific libraries already, very powerful libraries that you can use. Some will be the object of the course. So, and Python is normally considered very easy to grasp, at least at well, the first level. It's really easy. Already today we will able to do some, well, real world stuff, and it's also free software, so you can just download it from the website. It's available on any platform you can think of, and so it's really a good choice. Actually, there are others. So probably well, the Fortran is another choice. It's a very old one, but still very popular, especially in the numerical field and physics and so, and that's the same for the C language. Some of you have probably used also MATLAB or Mathematica or R. A new guy in the field is Julia. Julia is and that's probably the future, because Julia shares many good things of Python, and it's much faster than Python. So Python, the only problem of Python is that it's slower, but much easier to write than Fortran or even MATLAB. That's at a very high level. So that's the idea. Python is lower. We will during the course we will see a special Python library that it's NumPy that was actually designed exactly for doing scientific stuff similar to MATLAB, and well, if you use NumPy, Python is not that slower, but normally instead it's quite slower with respect to our competitors. Actually, that's not a problem for us, because I'm the kind of examples that we will see are probably not so numerically intensive to be so that the slowness of Python is not a problem for us. But in general, especially if you have to compute with very large numerical data, Python can be slower than alternatives. Both R or MATLAB are faster. Okay, so this is why we are looking at Python. I will also mention the fact that we will look at Python 3. The current version is 3.9, I think, or maybe it's 3.10 the last week or something, but well, we will use 3.9. And I mentioned this because actually Python 2, the previous version, is still very common, but deprecated. Actually, the Python Foundation killed it on January this year. So in January 2021, Python 2 was declared as dead and not, well, it doesn't get new stuff and so. So, and Python 2 is slightly, but in certain circumstances also has big incompatibilities with Python 3. So please, if you look around on websites or books or something, please note the version of Python they are using and stick to Python 3. And which kind of languages? And well, it's an imperative language. Actually, Python supports different paradigms, but we will focus on imperative programming. That's the more common way of doing programming. And imperative means that you give instruction to the machine to change something, and normally you change memory registers so something that can store data and the executing environment. So you both change locations in memory and the executing environment. We will now, well, in the following, we will understand better what does this mean. We will also see some of the object-oriented features of Python. object-oriented is a way we will talk about object from today, but actually object-oriented is a way to organize programs in a way that complexity is somewhat hidden and isolated. That's the idea. So it's just a way to organize stuff in a way that it does not make our head exploding. And
Excuse me, Prof.
yes,
There's a guy that cannot join Teams. I sent you a request to let him join. I was speaking to him on Zulip.
okay. So
He's
what's the
following on YouTube.
okay? That's fine. And maybe after this lesson, I can try to understand what happened. Okay. So if you cannot
Okay.
join Teams, I will. So maybe if it's on Zulip, I can just check the name. Maybe
I sent you a request. I don't know if you can
Eli
see it. Teams. Like, yeah.
Elias. Yeah. So it's actually Elias. Okay. Okay. I just added to the team, so probably we. But well, I actually added all the quantitative biology students. I had a list of them, and so at least from that course, everyone should be well, allowed to join the team. And I also added other people that wrote to me and that was interested. But anyway, so Elias is with us, I think, now, so we can try to go ahead. Okay, so thank you, Davide. And okay, so imperative object oriented. That's Python. It's that way. Okay, and another thing that I want to say is that this is a programming course. So I'm not a biologist, so I cannot really you know give you advice on that. I try to propose examples that, to me, that I'm not a biologist, seem related to your practice, to your daily biological practice. But I repeat it, I'm not a biologist, so I'm not sure. So maybe with your help, this course could improve. But now, at the moment, I'm able to just doing a classical programming course. And so that's actually an important thing. I think it's not that bad. So, well, programming can be useful in your work, but programming needs some, you know, reflection and digestion in some sense. And so I think that having in your bag of tools some solid knowledge of what programming is can be actually a game changer. And that's the idea of the course. And also, I want to notice a thing that I think it's a bit a problem, and then maybe a misunderstanding in general. And programming can serve two goals in science. So when you do programming for science, you can do that for two different things. And one is that with programming, you are, if you program something, you could, in principle, understand every detail of what are programming, what the of the computational process that you are describing, and that's really an important thing. There is a famous sentence by um, well, the physics. Oh, Feynman. Okay, an important, well, Nobel Prize. Feynman on the blackboard in his office on the last day. There was this written sentence. What what I cannot create, I cannot understand. Okay, so and if you want to really understand something, you must able to recreate that for yourself. Well, as biologist, you probably feel that a big milestone of biology was to be able to recreate life in a lab or something like that. So that's because we synthetically, I mean, no, we can always replicate life, but starting from life instead from synthesis. It's much more important milestone, and that's programming. It's that. So with programming, if you want to describe something with a program, you must describe every step in the process. So you have to you must have understood it in all the gory details. That's the idea, and that's a very important goal. But a second goal that's, I think it's much more popular around, but it's in fact another important goal. But I think that without the first a bit shaky. So the second goal is to put together stuff, very powerful stuff, because as I said, Python is full of Python, but everything in the world in which we live. There are around many very powerful components that we can just assemble by understanding very little about these black boxes that we put together. And that's also something that we can do with Python. Python is also called a glue language because it can glue together different stuff. Different, for example, machine learning libraries that do magic things, and without understanding the details of this. And that's in some situations, this is fine and wanted. But in general, this risks a lot to get many, uh, the movie, the Disney movie, the sorcerers apprentice. No? Okay, and that's the idea. The idea that if you use without a critical approach, without the critical thinking, these powerful building blocks, well, the results are not in your mind, are not really in your bag of tools, and so, well, you can maybe compute something that it's useful today, but you don't really understand the process, and you don't really you are not really able to generalize, use that in different situations and different cases, and so the goal of this course is mainly the first one, understanding every detail of the computational process. And in the last part of the course, we will try to use this background, this hopefully solid background, to also exploit the use of uh, powerful tools. That's the idea. There is this link, Teach Yourself Programming in 10 Years. I think it's a very nice short article that you can read to understand exactly what's the problem. And it is written by Peter Norvig, but now it's an important manager at Google, but um, originally was a artificial intelligence scholar, very important one. Okay, so let's start. Okay, do you have any comments, questions, anything that you want to notice now? Okay. So let's go to the fundamental concept. These are the concepts that will stay with us for all the course. And we will now today already try to understand them, and they keep to came out to come out in all the thing that we are going to do. And the first one is we have objects. Okay, so we have it doesn't matter what exactly an object is for the moment, at least. It's just something that it's important in your way to describe something. The goal of the program is to process some pieces of information. So you get some information, some pieces of information from something. Maybe it's a microscope or something, or so you get some data. Okay, you get, well, actually, before data, there is the information. So it's just something that happens, and you get something that happens in you try you get you interpret that as data. So you, with your way to see the world, that information is something for you. Okay, so you get so you measure something, and that measure, I don't know, 170 centimeters, that's information. But if it's 170 centimeters is the height of Mattia Monga, that's a datum. Okay, so that's a datum, and so you start from a datum, from data in general, so many data that you get from something, and you write a program that elaborate, process these data to get some other data. That's the goal of the program. and this process is automatic. So it's enacted by a machine, by something that works without human intervention. That's the idea. And so you have, in this process, you manipulate what in general in Python at least we call objects. So you have objects. I can just try to make a picture maybe. Let's see if I'm able to do that. Okay, so can you see that? Yes. Yes. Okay. So you have objects. That's a program is something that manipulates these objects. And in order to manipulate these objects, you need to have, well, those objects are all different, so they have an identity. So identity means that they are different and can be distinguished. And objects also have a value in the sense that you refer to object by names. Okay, so let's go back to the picture. So you have, for example, 4 objects, and you refer to them with, by names. It's also possible to have 2 names that refer to the same object. Okay, so names are something like, I don't know, x, or m, and that. So now here it's difficult to write for me, so maybe with text, okay? But names can be everything that you want, so not just one letter. So foo or super. Non lo so, I don't know exactly in English it's stuff. But anyway, what I want to say is that you have names and that refer to objects. So here you have 1, 2, 3, 4 objects, and you have 1, 2, 3, 4, 5 names that refer to them. Okay, that's the idea. And so you have these objects. You have the technical name of names is variable. So you have variables that refer to objects. And objects, what kind of objects you can use in your programs? Where you have objects are taken from some types. What is a type? A type is just a set, okay? And a set, but together with the operation that make sense on that. Okay, so you have, for example, the basic types that are the integers, floats, that a computer science approximation to real numbers. They are not real numbers, unfortunately, but it's a compromise between mathematics and efficiency. So you have integers, floats, strings, function, and that can be also composed in something more complex. So you have arbitrary types. We start with basic ones, but you can put together to build some, I don't know, a cell or an animal or something like that, and reason on that. That's the idea of also object orientation, and so you can compose that. But now we will just use the basic ones. Strings is just the computer science name for a sequence of characters. That's the idea. Okay. So you have objects, names, and those objects are taken from pre-designed sets. For example, the integers, the floats, the strings. That's the idea. So coming again to my picture, this could be the this could be the number 3. Let's say that. Okay. This can be the number 3. This could be the string MA. This can be the number 5 and so on, or the number 3 dot 14. Okay, 1, 4. Okay, that's the idea. So this would be an integer, this would be a float, and this would be a string. Okay, and this integer value, this is an integer value that is known by the name x and by the name foo. That's the idea. Okay. So that's the basics of every program. Every program has something like that, and every program has to deal with this. And there is another thing that I want to notice, but it's that there are also some special commands that actually are a bit different of it. So normally the word of your program is made by those 3 things. So variables, objects, and objects are taken from basic types. Even a very complex Python program is made of this stuff, always. But there are also some special commands that do special things. And I mean, you cannot notice that from the beginning at least, but I think it's an important distinction to make, because actually those special commands cannot be programmed in Python. So if you hadn't those special commands, you could not do something. For example, something very basic, for example. So writing a thing on the screen, for example, that's normally the first thing that one does with a program, is actually not something that you can do in Python. But you must do that with a special command that Python provides to you, because actually writing on the screen is something that it's normally reserved for the operating system. So you cannot writing something on the screen. You can ask to the operating system to write something on the screen, and the operating system decides if the writing has to be done. That's the idea. So those are the ingredients of every program: object, basic type, variables, and special commands. We will see very few of them, but it's important to make the distinction, because it's something that, well, we say that we want to understand every detail, and actually those details are not understandable without referring of the secrets of the operating system. That's why I think it's important to notice the difference.
Excuse me, Professor.
Yes?
I'm currently seeing the whiteboard, not the slides.
I'm sorry. Yes, I forgot it. Yeah.
Thank you.
Okay. So, but actually, the slide was always the one that I showed before. Anyway, those those special commands. Oh, sorry, I crazy. Okay, those special commands are something that you ask to the operating system. In fact, they are called system calls. Okay, that's the idea. And this is the what we computer scientists call the onion model. That's, you know, those are the onion rings. Okay, so the like an onion is made by different you know, rings in English, and the basic idea is that you have a physical machine, the green one, the green stuff here, and actually the the green stuff is hidden behind the operating system. So you never talk directly with the hardware. And with hardware, I mean also the peripherals. So, for example, a microscope or some other biological instrumentation. I don't know. Again, I'm not a biologist, but something that you want to use is this green stuff, and you cannot use that if the operating system doesn't provide you an interface to that. So this the blue stuff is all software, but it's important to distinguish between the operating system and the application. And actually, the Python interpreter itself and the programs that you can write in Python are all application. So they are in this external ring. Okay? And so they actually don't program the green hardware, but they program the so-called virtual machine provided by the operating system. That's a very important concept, and something that you will forget very soon, because actually when you program, the language doesn't distinguish from something that it's a special command and something that it's not. But it's important to have in some part of your mind, because in many critical situations it matters. Okay, so that's the idea. So let's try. Okay, so there's with I think my my goal for the this course is to make a very practical one, so not a theoretical one. So well, maybe today I talked a lot, but basically during the lectures we will try to do stuff. So try to write program and understand the difficulties of writing programs, but also the fun in that. And so, for the first lessons, we will use this platform that you can find at this address. I think I can show you. This is the stuff we are going to use. And you can use that also without an account, so as you want, but it's useful if you create an account, because you can ask for help directly at me or maybe Davide, and so please do that. Also, if you create an account, it's easier to to remember the things that you wrote and something like that. So, create an account. My account is mmonga, and if you go in the profile, you can choose a guru's username. Okay, so if you here put my name, mmonga, I put it in the slide, I think, yes. Okay, mmonga. This is the username of your guru, and when you do something, you can, for example, not here, it's just an example. Well, when you have an exercise, here is an exercise, I can write something like that, and you can ask to a guru. I have no gurus that can help me. I'm my own guru, but you can just ask for help here, and it's very convenient for me because I receive exactly what you wrote in the exercise and so on. So for starting out, it's very convenient. That's the idea. This stuff is actually not my own work. It's made by University of Waterloo, but it's free software also, so I install it on our machines and we can use that. And that's the idea. Okay, so the name of this stuff is CS circles. So when we will refer to that as CS circles. So let's start and let's try the first things. I think that maybe from my my picture here, you already learned that the basic operation in Python is to give a name to an object. So drawing this kind of arrow. And so that's the idea. So let's try some stuff on CS circles. And so the idea, you can read everything, of course, if you want. But now we will just try some stuff, just to show you how it works and how you can use it. So for example, this is your first Python program. And in this Python program, there are some of the stuff that we saw before. This is a special command. This print command is a special one. And it's a command by which we we ask to the operating system to write a string on the screen. And if you click on Run Program, the program runs and writes, in this case, not on the screen, but via the browser. You are writing "Hello World." That's the string that is written here. That's the idea. So print is a special command, and that's the nice stuff of CS Circle is that you can do the exercise, the examples and the exercises, but you can also use this console. In the console, you can just write an arbitrary Python program. So for example, you can write what we call an assignment. And this is an assignment. This is it means that the name X is assigned to 3. Or I suggest you to read this line as X becomes, okay, not equal, but X becomes 3. Okay? This is not the mathematical equal. That's very important. In fact, in other languages, they use sometimes some asymmetrical symbol like something like this. And this is not Python, but R, for example. But anyway, the important thing is that the left side of this stuff has a different role of the right side of that stuff. Here you can just have names, and here you can just have objects. So after that, you can, for example, print the value of X. So of course you can print 15, and this writes 15, but you can refer to an object by its name, so print X, and you get 3. And of course you can also have names that refer to the same object as our name. So Y becomes the object referred to by X. And so if you write on the screen Y, I think you are not surprised to get 3. Okay, this is the basic operation that we will repeat well, very large number of times, because this is essentially the most important operation of all imperative programming. Imperative programming is normally about assignments. That's the idea. Of course, we can try also to do an exercise. Of course, if here we are requested to write a program which prints this string. Of course, if we print 3, the program did not pass tests, and so this is incorrect. Instead, if we want to print this stuff, so we put this here, and this is not correct because that's not a string. To get the string, we need to use the quotes. So you should use the quotes. And if you run this program, everything gets green because this is the right answer. There is not just one answer. You can answer in different ways. Okay. For example, to delimit a string, to say to Python that these characters compose a string, you can use the double quotes, but also the single quotes. and that's another correct program. That's the idea. Okay, and there are an infinite way of doing the same thing. For example, we could say also that x is the string, and so you can print x. That's the same program, but written in another way. Okay, so that's again. But maybe you can do something like this. You can have two strings. Okay, so the string, well, maybe this stuff. Okay, and you can then print x plus comma space plus y, and that's again is the right the answer is correct. Okay, that's the idea. Okay, here you can see all the program that you wrote, and as you see the okay. Okay, it's on the other page. This one was incorrect. Those are correct. Okay, so if you write this stuff when you are connected with your account, every program you submit is preserved, so you can also see the evolution of your learning achievement. Okay, let's. Do you have any questions? So let's go back to the slides. So you have well, assignment is this stuff. So you have a name, becomes the equal sign is actually the assignment operation, and so you are assigning this value to this name. Okay, that's the idea, and I suggest you to read in your mind as becomes. That's the if you read as becomes, you never get it wrong. Okay, of course, the same name can be assigned to different objects. So, for example, Mattia and Violetta, and an important thing again is that basic objects are always immutable. So when you work on them, when you process them, you actually create new objects. Okay, so if you, for example, concatenate two strings, so you put one after the other, this is not the initial string that is modified, but is a third string coming out from the operation of adding or concatenating the two strings. Okay. Oh, another thing that you can do with CS circles that it's very useful, and unfortunately students sometimes see this kind of stuff as something that just beginners do, but it's actually not true. Everyone, also people who program since I don't know 20 years or so, when you want to understand exactly what your program is doing, you normally use this technique called tracking. What is the tracking? Tracking is just to take a piece of paper and try to understand which you have in your program. You have I don't know 10 important names, 10 important variables, and you follow what happens to those names during the execution of the program. And so you try to understand, and that is something that you must do if you want to, if there is something that you don't understand. And you have to do that with the paper of something that I now will show you. Because your mind, our mind, is not accustomed to think step by step. Our mind loves to reason at high level or in a holistic way somewhat. And but if you want to understand exactly what our program is doing, we must reason on all the steps that the program is doing. And you cannot do that by mind, by heart, by just referring to, well, if a program is very simple, maybe you can also do that just in your mind. But also not so small programs, still small, but not so small programs, it's not possible to understand them without taking some paper or tracking in another way all the names involved. So I will show you that the CS Circle stuff has a very nice tracking tool, but it's something that you can where is it? Or maybe this program are too simple and there is no, let's see if it's here. No, it's not here. But normally there is a button called visualize. Let's see this step. Okay, that's the, I cannot find here, but it's this stuff. Okay, and if you write something here, so for example, x becomes 3, y becomes x plus 3. Well, let's print x, print y. Okay, you can visualize execution. This is what I call tracking, and you can see exactly what Python thinks about your programs. So that's the idea. For example, you see here you have 3 steps and you can visualize every step. So for example, after the first step, you have this name and this object, and this name refers to this object. After the second step, you have 2 names, and look, here you have x that was 3, 3 plus 3 is 6, so y refers to 6. And that's the idea. So I cheated a little because actually the numbers are not tagged as object in this picture, but you can actually think of them exactly as they will be objects. Maybe it was better if I used some Okay, so okay. Also, well, strings are not object also for this stuff. But anyway, it's not really important because they are. It's the same. The name refers to something, so it's not a problem that technically they are not object. And and this is tracking the program. So you are following what happens in the memory, in the stuff, the frames, the word of the Python program after each step. And you can go back or forward. And that's very useful, not in this case, but when you are trying to understand why your program doesn't do what you wanted, probably this kind of stuff can help you a lot. Or if you want to understand what a fragment of program does when something that someone else wrote for you, that's a good way to understand what happens. Okay. So let's say the last thing that I want to say today. Okay, we already saw some of the operations. So for example, you have binary operators like the plus. You have also unary operators like minus. So minus 5 means minus 5 means take the opposite of minus 5, something like that. So operators are mostly for the numbers, but also for the strings. We already saw that the plus with strings just concatenates them. In general, you have what is called a function. For example, the function max. What we expect from something called max? Well, max takes the maximum of a sequence of numbers, for example, but also a sequence of strings. In that case, they are ordered by the alphabetical order. Anyway, when you use a function, you are not, well, with the binary operator, you have two objects. With the unary operator, you have one object. With a function, you can have zero object or whatever. Okay, so it's not a problem to have. For example, max takes a number, an arbitrary number of parameters, they are called. So you can use max with one parameter at least, but 2, 3, 4, as you want. Okay, so for example, if you write let's here, okay, so max between 3 and 67, and we so y becomes max, and what you expect. Of course, the maximum between 3 and 67 is 67, and so that's what you expect. But you can also have whatever. Yeah, that's okay. Again, it's still 67. So this is a function, and those are called the parameters or the arguments of the function. So in this case, we will say that max takes 4 parameters or 4 arguments and actually returns a value that is given to y in this case. Okay, so the result is the return. It's also called the return parameters of the stuff. let's go back to the slides. Sorry. And so function, and again, you have special commands that are not important from, sorry, they are syntactically the same functions, but again, in some part of your mind, you should remember that they are strange things that do something like print is not actually function, it's something that requests side effects to the operating system. So it's something special. Okay, so let's take, and here's the last thing that I want to say today. Let's take this kind of exercise. I think it's the last one in here. Okay. So exchange the value of two variables. Okay, so let's read what does this means here. Okay, so swap, exchange the values of two variables. Please read all the exercise here. It says that the grader, what is the grader? The grader is actually the program that will say if your program is correct or not. So the grader is actually a complex program and do stuff. So does stuff. So for example, it defines already, will automatically defines two variables, variable x and y. So in this program that you have to write here, you cannot use the names you want. You have to stick to the names that the grader is using. If you want to be graded by the grader. Okay, that's the idea. So you have two variables that you don't define because they are defined by the grader. Okay, so yeah, and you must use those variables, those names, and exchange, swap the values of two variables. Okay, so how do you do that? Anyone want to try?
Do you need another variable?
Okay, so you need another name, for example, TMP, for example, and TMP becomes what?
X.
Yes. And after this,
And after we have to put y.
so Y becomes X, I think. No,
Yeah.
yeah, X. And,
Yes.
yeah, and is it finished?
No.
Okay.
Another time TMP equal x.
TMP equal X. Okay. So let's try to visualize what happens with this stuff. Edit code. Okay. Okay, so let's, we have no grader here. So we have to define X and Y. So let's follow what you propose. Okay, so that's the idea. Now you have TMP is free. and y is free, look, the 5 is already lost. So, not the 5, sorry, it was a 6, sorry. You need to let's do it again. 3 and 6. What we want is that in x we have 6 and in y we want 3. That is swapping. Do you agree?
Yes.
So you save the 3 in TMP, you put 3 in y, and then you put x again TMP, and that's not what we want.
No.
So
Mm,
what's the right code to write?
I think in the second line it should be x equals y.
Yes.
And then
I prefer to say becomes, but yes. Okay, so x
okay,
becomes y. That's right. And then, is this
and then the
correct?
last
And
the last line it should be y becomes temp.
exactly. Sorry. Y becomes okay. Now we can follow it again, and it's temp. It's 3. X is 6. So now the two names refer both to 6, but the 3 is saved in TMP, and so that's the idea. And so now at the beginning we had x was 3, y was 6, and now x was is 6 and y is 3. Okay. So no, where it is? Okay. So that's the idea. So y is, so I save it there. So x y, and y is t. That should be the right thing to do. Okay. And here you test it with different values. And that's it. So this is a very simple exercise, but what it's actually something that gives me the opportunity to say something about general strategies. And what I want to say is that, okay, so to solve this exercise, you have to know about variables and assignment. You have to know the meaning, the semantics of what you are writing. That's clear. And how can you think about this problem? Actually, you probably thought about something that you do in your normal life. So if you want to exchange what it's in some, for example, boxes, you cannot put two things in a box. Probably you understand clearly that to exchange the content of two boxes, you need a third box. Okay, so that's a natural way to think about this stuff. Or if you in your life you probably had the chance to change, I don't know, for example, the names of exchange the names of two folders in your so Windows desktop, and so for exchanging these two names, you need a third name, a temporary name or something like that. And so this is a quite natural strategy. So when a problem, as this is something that you do also in your real life, normally it's not that hard to think about the program. You just follow what is in your mind and just translate it in Python. And so it's something that you learn quite quickly normally. But actually, there are two other strategies that can be important in solving problems. And one is the so-called, this name is a name that I invented, so it's not a general name. But what I call the Fox strategy, it's you can sometimes you can solve the problem by knowing some tricks, some library tricks, some specific library that already does what you need, or some language specialty that can help you. For example, in this case, you might know that there is not just the simple assignment, but in Python it's actually possible to do a multiple assignment. So the same problem, okay, can be also solved by using this stuff, and in that way you don't need also the temporary variable. And that's what you can write down using by the multiple assignment. What's the syntax of the multiple assignment? The multiple assignment uses the same symbol, so the same becomes symbol, but on the left side and on the right side you have multiple. On the left side you have multiple names, and on the right side you have the same multiplicity of objects. And so in this case the object referred by y is assigned to x, and the object referred by x is assigned to y. And so this is also a correct program, as you can test. Okay, and but the first solution was something that you build by thinking about your natural way of doing stuff. In this case, you were like the foxes, that know everything, that are very smart and know languages, tricks, libraries, and something like that. That's the idea. And I actually believe that this is a possible strategy, but it's actually a strategy that means that you have to study a lot of libraries and a lot of tricks of language and so probably it's not what it's available to you at the beginning, but it's something that it's after some experience, something better. And I don't want to. This is exactly the point that I was making at the beginning of this lecture. I don't want to approach this course like a fox. It's not like that. I want to. I will not spend my lectures to give you tricks. It's not the goal of the course. Because, tricks are also easy to forget. If you don't use them for a while, you don't know anything about that anymore. So another possible strategy that I want to mention it's what I call the hedgehog strategy. So the hedgehog strategy is another interesting approach to the problem. When you have a problem, you can become an expert of that problem. You can become someone who knows everything about that problem. So for example, in this case, we have to exchange numbers because the exercise says that we are exchanging numbers. And we can think about some, arithmetical property, for example, that helps us. And this is actually a way of solving the problem in totally different way as before. Again, we can use just two variable, no need for a third name. That's not a problem, but let's say. So for example, we can say that y x is x plus y, and so what we did here, we put together the two numbers. So the two numbers are together in x. So after that, we can put in y becomes what? Become the two put together, x, minus the y. Okay, minus the original y. Okay, and then we do the same but with x. So x become again the two together, x minus y. It's the new y now. So again, that's the, and this is, oh, it's right. And it's something that I can think about just because they are numbers, but just because I'm an expert of arithmetic, and well, it's not easy to convince yourself that this works in every with every value of x, y, and of x and y. We can just try to visualize it, for example. Let's yes, here, visualize. Okay, and let's visualize that. Sorry, I forgot that the grader defines, for example, 3 and 5. So let's visualize this. Okay, so 3 and 5, we want to swap them. So x becomes the two together, 3 plus 5, 8. Then you take the 8 and subtract the 5, and you get in y the 3. So in y you have the old x, and after that you get again the two together, 8 minus the y, that's now 3, and so x is 5, and so the two values were swapped. Okay, that's the basic idea of this strategy. So I call this the hedgehog strategy because this doesn't mean that you so the famous dictum is the fox knows many things and the hedgehog just one, but very good, in a very good manner, and that's the idea. So you can it's not easy to invent this kind of solution. This is the the one that you probably can, and the natural strategy is something that you can probably invent. Okay, so the natural strategy is something that you can invent by thinking of what you do in your normal life. It's probably very hard to invent this kind of strategy. So to be able to invent this kind of strategy, you have to have a familiarity with numbers that because you are an expert of arithmetic. So that's a general way of approaching the solution of the problem. Again, you will become a good programmer in 10 years, 20 years. At the beginning, you should probably focus on the natural strategy. So on try to do some stuff on the paper, and when you are able to do the stuff on the paper, you can try to translate it in Python code. Okay, that's the beginning of the way in which one learn to program. After that, after when you have some more experience, you can try to find some tricks, or you can try to understand the problem in such a way that you can find some very smart way of doing the stuff. Okay. So let's finish this lecture, actually a bit late. So, the last slide say that you have to do some homework. The next time we will see is on Friday. So you have 3 days, and I hope you are able to do all the chapters on CS. So they are very simple, so you have to just read them and try all the exercise them there. I think that you can do all the stuff in less than 3 hours, maybe less than 2 hours, I don't know, it depends on you. Maybe next time I will ask you how long did it take to finish all the exercise, but please do that, because in programming the exercising is crucial. There is no way of learning programming without writing program that at the beginning simple programs, and after that programs not so small, and so, but you must program, you must write programs without referring to the solutions. So you must try to write them from zero. That's the idea. It's not useful to remember solution. The only useful thing is try by yourself writing something, and maybe writing something wrong, discovering why it's wrong, and try to improve yourself with a new program. So writing wrong stuff, it's perfectly fine, and it happens, and it's exactly because you write wrong stuff that you learn how to write correct stuff. That's the process. So don't be afraid to make errors or mistakes, because it's perfectly normal, and it's actually useful to improve. Okay, so that was my lecture. So if there are any questions or comments or anything, I'm here.
Sorry, I didn't understand where are these homeworks.
Well, here on CS circles. So in CS circles, you have to do 0, 1, one E function, so, and all the stuff, and, 1, 2, 3, 4, again. And we will start again on Friday from 5. If you want to to do more, it's not you know.
Okay, and the
You
link
can.
on
The
the
link is on the slides that I will put on the website. But anyway, it's Manin Docenti di Unimi IT. Okay. But anyway, I will now I will publish the slides.
Okay, thank you.
Okay.
And sorry, the recording of the lessons will be on YouTube?
Yes,
Okay.
yes. It will be on the same link that for the live session. Okay. But again, I will publish it on the website. Remember to answer the survey, subscribe to Zulip, and enjoy your week. Okay?
Okay, thank you.
Bye-bye.
Thank you. Bye.
Thank
Have a
you.
good day.
Bye.
Bye.
Bye.